Q6186. Streamers of precipitation trailing beneath clouds but evaporating before reaching the ground are known as A. Virga, B. Sublimation, C. Condensation trails. The correct answer is A. Streamers of precipitation that trail beneath clouds but evaporate before reaching the ground are known as virga. Virga occurs when rain, snow, or other forms of precipitation fall from the cloud but evaporate before reaching the Earth's surface. In the atmosphere, there are often layers of dry air beneath the clouds. When precipitation falls from the cloud into these drier layers, the surrounding air quickly evaporates the moisture droplets or ice crystals, causing them to dissipate before they can reach the ground. As a result, the precipitation appears as visible streaks or streamers descending from the cloud, but not making it all the way down to the surface. Virga is commonly observed in arid or desert regions where the lower levels of the atmosphere are exceptionally dry. The process of evaporation during virga can have a cooling effect on the air, leading to gusty winds or downdrafts beneath the cloud. It is important to note that while virga may give the appearance of rain or snow falling from the cloud, it does not reach the ground to provide significant precipitation. This phenomenon is distinct from actual rainfall or snowfall, where the precipitation reaches the surface. In summary, virga refers to the streamers of precipitation that descend from clouds but evaporate before reaching the ground. It is caused by dry layers of air in the atmosphere that quickly evaporate the falling moisture or ice crystals, resulting in visible streaks or streamers of precipitation that do not reach the surface. Q6183. What is the process by which ice can form on a surface directly from water vapor on a cold, clear night? A. Sublimation, B. Condensation, C. Supersaturation. The correct answer is A. The process by which ice can form on a surface directly from water vapor on a cold, clear night is known as sublimation. Sublimation occurs when a solid, in this case, ice, transitions directly into a gaseous state without passing through the liquid phase. During a cold, clear night, when the temperature drops below freezing, water vapor in the air can come into contact with a cold surface. When this happens, the water vapor bypasses the liquid phase and undergoes sublimation, transforming directly into ice crystals on the surface. Sublimation is the reverse process of deposition, where water vapor transitions directly into ice without becoming a liquid first. It is important to note that sublimation can occur when the surrounding air is below the freezing point, even if the surface temperature itself may not be at or below freezing. On cold, clear nights, surfaces such as car windshields, plants, or any exposed objects can experience sublimation as water vapor in the air freezes directly onto them, forming a layer of ice. In summary, sublimation is the process by which ice can form on a surface directly from water vapor on a cold, clear night. It involves the transition of water vapor into ice without going through the liquid phase. This phenomenon occurs when the surrounding air is below the freezing point and the water vapor comes into contact with a cold surface. Q6184. Which precipitation type usually indicates freezing rain at higher altitudes? A. Snow, B. Hail, C. Ice pellets. The correct answer is C. When considering precipitation types at higher altitudes, the one that usually indicates freezing rain is ice pellets. Freezing rain occurs when there is a layer of above freezing air above the surface, causing rain to fall as liquid and then freeze upon contact with objects or the ground. Ice pellets, also known as sleet, are small ice particles that form when raindrops freeze during their descent through a sub-freezing layer of the atmosphere. These frozen raindrops do not have enough time to fully freeze into solid ice before reaching the surface, resulting in the formation of ice pellets. At higher altitudes, where temperatures are colder, the presence of ice pellets in the precipitation indicates that there is a shallow layer of sub-freezing air. As the raindrops fall through this layer, they freeze into ice pellets before reaching the ground. In contrast, Snow refers to the solid form of water vapor that crystallizes in the atmosphere and falls to the ground. Hail, on the other hand, is formed in thunderstorm clouds through complex processes involving strong updrafts, and it typically falls as larger, irregularly shaped ice pellets. Therefore, in the context of higher altitudes, the presence of ice pellets in the precipitation is a strong indication of freezing rain, where raindrops freeze into pellets before reaching the surface. 6187. From which measurement of the atmosphere can stability be determined? A. Ambient lapse rate. B. Atmospheric pressure. C. Difference between standard temperature and surface temperature. The correct answer is A. Stability of the atmosphere can be determined from the measurement known as the ambient lapse rate. The ambient lapse rate refers to the rate at which the air temperature changes with increasing altitude in the atmosphere. The stability of the atmosphere is influenced by the behavior of the air parcels as they ascend or descend. When the ambient lapse rate is lower than the standard lapse rate, which is the rate of temperature decrease with altitude under standard atmospheric conditions, the atmosphere is considered stable. In a stable atmosphere, air parcels that are displaced upward or downward tend to return to their original position, indicating resistance to vertical movement. On the other hand, if the ambient lapse rate is higher than the standard lapse rate, the atmosphere is considered unstable. In an unstable atmosphere, air parcels that are displaced vertically experience accelerated upward or downward motion, promoting vertical mixing and the potential for the development of clouds, precipitation, and other atmospheric disturbances. By comparing the ambient lapse rate to the standard lapse rate, meteorologists and atmospheric scientists can assess the stability or instability of the atmosphere. This information is crucial in understanding and predicting weather patterns, convective processes, and the potential for severe weather events. In summary, stability of the atmosphere can be determined by analyzing the ambient lapse rate, which refers to the rate of temperature change with increasing altitude. Comparing the ambient lapse rate to the standard lapse rate helps identify whether the atmosphere is stable or unstable, providing insights into vertical air movement and atmospheric conditions. 6188. The formation of either predominantly stratiform or predominantly cumuliform clouds is dependent upon the A. Source of lift. B. Stability of the air being lifted. C. Percent of moisture content of the air being lifted. The correct answer is B. The formation of either predominantly stratiform or predominantly cumuliform clouds is dependent upon the stability of the air being lifted. Stability refers to the tendency of the atmosphere to resist vertical motion or to promote vertical motion. When the air being lifted is stable, it means that the environmental lapse rate, the rate at which temperature changes with altitude, is relatively low. In a stable atmosphere, the lifted air parcels tend to be cooler and denser than the surrounding air, inhibiting their upward movement. As a result, predominantly stratiform clouds, which are flat and layered in appearance, tend to form. Stratiform clouds often cover large areas and have a uniform and smooth appearance. Conversely, when the air being lifted is unstable, the environmental lapse rate is relatively steep. In an unstable atmosphere, the lifted air parcels become warmer and less dense than the surrounding air, promoting their buoyant ascent. This leads to the formation of predominantly cumuliform clouds, which are characterized by vertical development, distinct shapes, and the presence of individual cloud elements. Cumuliform clouds often appear puffy, with well-defined edges and a towering structure. The stability of the air being lifted is influenced by various factors, including the temperature distribution in the vertical, moisture content, and the presence of atmospheric features such as inversions or frontal boundaries. Understanding the stability of the air is crucial in predicting cloud types and assessing the potential for severe weather phenomena. In summary, the formation of predominantly stratiform or predominantly cumuliform clouds depends on the stability of the air being lifted. Stable air tends to produce stratiform clouds, while unstable air promotes the development of cumuliform clouds. The stability of the air is determined by factors such as the environmental lapse rate and the temperature distribution in the vertical.